Hey everyone. If you can hear me, go ahead and raise your hand. Awesome. Cool, thank you. I see lots of hands raised. You can go ahead and lower them now. If you can, just by clicking that same button. So hi everyone, my name is Holly Grand. I work with Texas Parks and Wildlife Department in our Coastal Fisheries Division. Before we get into what we're actually here to talk about today, the fun stuff for Shark Week, I do want to go through a little bit about how the Zoom webinar is going to work. I think by now we're all pretty familiar with webinar and these virtual programs, but just in case there's some new folks here, I do want to cover that for us. So during the presentation, during the program, I'm probably going to be asking you to raise your hand a few times to answer questions for me, just so I can see what you guys think about what I'm talking about. So again, some of you have already located that button when I asked you if you could hear me. If you could not find that button before, it should be towards the bottom of your screen. And that should be true both if you're on a computer or if you're using like an iPad or an iPhone to connect with us today. So again, that's towards the bottom of your screen. And try to lower your hand when you're done answering the question. It shouldn't be a big deal if you leave it up, but just remember to click that button again, just to lower your hand. We are going to have some time towards the end of the presentation today to answer some questions. On the bottom of your screen, again, you should be able to see a Q&A button. So you can answer or ask your questions by using that Q&A feature. There's no chat in this webinar today, so we are just accepting questions, again, through that Q&A feature. I probably will not be answering them live as they come in, but you can submit them at any point during the presentation and we'll get to them at the end. So if you don't want to forget a question that you had while I'm talking, go ahead and type it in and we'll get to it towards the end again. And I think that covers everything as far as like Zoom goes. So I hope that it goes pretty smoothly for you all. And we'll get into it. So like I said, my name is Holly Grand. I work with Coastal Fisheries Division of Parks and Wildlife, and we are celebrating Shark Week this week with a few different webinars. We're starting it off today with our shark dissection and shark anatomy presentation. So what I want you guys to do, we're going to get a chance pretty early on here to talk about or to practice raising our hands. So I want you guys to raise your hand if you have seen a shark before. So it doesn't have to be one that you've like held live, but maybe you've seen one in an aquarium, or maybe you've been out fishing with someone who caught a shark. Awesome. I'm seeing so many hands raised. Wow. That's pretty impressive. Almost half of the people that we have in here today have seen a shark before, which is really cool. So either keep your hand raised or raise your hand now if you're looking forward, if you're ready to see the shark that we are going to be talking about today. So many people, almost everyone. And there's a few people who aren't raising their hand. And if it's just because you can't find your button or can't click the button, or maybe it's because you're not looking forward to seeing our sharks today. If you are not wanting to see like the actual dissected shark, we're going to be doing that towards the end of the presentation. I'm going to be giving plenty of warning before we get to that. So if maybe looking at the inside of a shark isn't what you're necessarily interested in seeing, you will have time to close out of the webinar before then. Or just leave when we get to it if you decide it's not something that you're necessarily wanting to see. But we will give you a heads up. It will take us a second to switch over from this camera here to a different camera where we have the shark set up. So again, I will give you notice. You'll have plenty of time to leave if you need to or if you want to. So let's get this shark out. What do you guys think? All right. So this is the shark that we're going to be talking about today. And he's going to be helping me point out some of these external structures for the rest of the presentation, or at least for this first half here. This is an Atlantic Sharpnose Shark. They're pretty common along the coast of Texas here. I don't know a ton about where this exact shark came from, but I'm in Corpus Christi right now, and I got him from one of our local field offices. So if I had to guess, I would say that he came from the Gulf of Mexico, probably somewhere off the coast of Corpus. And I don't know how he ended up in our possession exactly, but he came from one of our law enforcement officers. So again, if I had to guess, he was probably taken from an angler who maybe had him illegally. So sometimes when we end up with sharks or fish or anything that is already dead, we will sometimes take them and keep them in our possession to use for education and outreach purposes. So that's why we have him here, why we have him in our freezer, why he's with us. So it's not just like something we went out and caught this shark to use for this presentation today. So I said he's a sharp-nosed shark, and it's going to be really kind of hard to tell because I think my fingerprints are leaving some of these spots on him here, but the sharp-nosed sharks, they get to be about, let's see, just over 30 inches or so when they're an adult. This one that I'm holding is at about 32 inches long. And I've got another one off to the side that's about 24 inches long. So this is our adult sharp-nosed shark. So raise your hand if you would think that if you were to see this shark in an aquarium or out in the ocean, would you think that this is an adult shark or no? So raise your hand if you think that this would be an adult shark. A few people, right? So from what I know about sharks, which is, maybe not a ton still, even though I do get a chance to work with them a little bit more frequently than a normal person may be able to, I still would not expect to find a shark this big. So at its adult size anyway. So it's always a little bit surprising to, again, see that an adult shark can be something as small as this guy here. And again, to identify it as a sharp nose, they have a really pointy snout here, and then they have white spots on their side. These two are fingerprints from me. He's still a little bit frozen, so we're leaving some marks on him, but maybe able to see this spot back here too. All right. So some of the first features that I want to point out on this guy here are his fins. So he's got a few fins along the top of his body here. These are his dorsal fins. So this is what you're probably most familiar with when you think about a shark, right? You think about these dorsal fins breaking the surface of the water and seeing them kind of like right at the surface. And these are really important to sharks because it helps to stabilize them and helps to keep them upright in the water. If we then let's go to these fins here. Let's see if you can see both of them. So these fins on either side of his body here, these are his pectoral fins. So these help with steering. So think about if you were like driving a car, it'd be really important to steer, right? So that's what these two fins here are good for. If we move down, I'm gonna flip them over because it's easier to see on this side. We have his pelvic fins here, and then his anal fin is here. And of course, we've got his long tail, right? So this tail is really important because it helps the shark to move through the water really easily, right? This tail fin is also called a caudal fin. All right, so the next thing that I want to talk about is his mouth, which you can see here. So he's still a little bit frozen, and it's going to be really hard for me to pry his mouth open to show you this one's teeth in particular. So what I'm going to do instead is I have a shark jaw that I want to show you instead. Thank you. So we've got this shark jaw here. I don't know what kind of shark this came from. I don't know where it came from. I just had it in with a bunch of my stuff here. But it's from a larger shark also than what we're working with here today. So really the important part of the mouth that I want to show you, they have a ton of teeth, right? A ton of really sharp, razor sharp teeth. And I'm going to try to get up close to the camera here so you can see. It may be a little bit hard with the lighting. Let me see if the bottom's easier. Yeah, it's easier with the bottom. So you should be able to see at least one additional row of teeth back behind the ones that are in front. They actually have several rows back there, but again, it's kind of hard to see because the lighting in here isn't ideal. But what's really kind of cool, kind of important is that as soon as the shark loses one of its front teeth, I guess we'll call them, those teeth that are waiting back behind there, they'll actually pop right up into place, kind of like a conveyor belt, and replace the shark's tooth that went missing. So throughout their entire life, they're just kind of always replacing teeth that they lose. So I want you guys to raise your hand if you think it would be cool if our teeth worked like this. I'm seeing a few hands. I think it'd be interesting, right? I don't know how I'd feel about it necessarily. We were talking earlier that it might be a little bit painful, but it'd be interesting for sure. Let's see, maybe about half, less than half of you guys think it'd be interesting. Okay, so thank you for answering my fun little question. The next thing that I want to talk about with the shark, we're going to pull our sharp-nosed shark back out here. I want to show you guys his nostrils. So he's got 2 nostrils located on either side of his snout here. And those are really important for smelling. So with our noses, we can smell and we breathe through our noses, right? Sharks do not breathe through their noses. So their nostrils don't like connect through to anything else besides just like it's almost like a little pouch that they have, and water flows into the little pouch and then it'll flow back out of the pouch. But inside of there's little receptors that are sensitive to chemicals in the water. So those chemicals can be like blood, or they could be, I don't know, something else from a fish that they may be wanting to smell to try to find food to eat. Yeah. Sorry, he's a little cold, so I got to set him down sometimes. The next thing that I wanted to point out, though, are his ampullae of Lorenzini. So these, I don't know if you can see it on this camera. It's really washed out. So what I'm going to do is I'm actually going to show you guys a picture of this particular shark's snout. Let me share my screen really quick. All right. So you should be seeing a picture of the shark. And you can see all those little black dots that he has on his snout, right? So those are called ampullae of Lorenzini. So those are little receptors that help them detect electrical signals in the water. So anytime a fish makes any sort of movement, whether that's swimming or maybe breathing, like even pushing water over its gills and moving its operculum, moving its mouth, those fish are releasing electrical signals. And those receptors that the sharks have are really important because they can help the shark to find prey items that may be hiding, whether that's in some sort of like habitat, or maybe they're hiding underneath the sand or something. They use those to sense where a fish maybe is being really, really still and not moving a ton, but it can still sense them that way. So again, that helps them to be really successful predators, along with those nostrils that you can see probably a little bit better on this photo, right? Which again, help them with chemicals, and then the ampullae of Lorenzini help them with the electrical signals. Okay. I have maybe one more thing to show you on this side of the shark, and that's going to be his gills. So we've got 5 gill slits. Well, yeah, 5 gill slits here. The last one's kind of hard to see, but it's over here. And they're external gill slits. So if you were to think about another type of fish, maybe something like a goldfish or a bass or a redfish or whatever kind of fish that you might catch if you were out fishing, they have what's called an operculum that covers their gills. Sharks don't have that. Their gill slits open right up to the outside. And that is really important because it helps them to breathe. So what they'll do is they will swim forward through the water. Their water will enter the shark's mouth and pass over the gills and then exit through the gills of the fish. And when it's passing through the gills and back out into the environment, there's a bunch of blood vessels in the gills. So the oxygen that's in the water will make contact with some of those blood vessels, and they'll get absorbed into the shark's body and then transported throughout. And that oxygen is really important in helping our sharks survive, right? We need oxygen as well. We just get ours from the air, and the sharks and other fish and other critters that live out in the ocean or in any other body of water, they need to take in their oxygen through the water itself. And that's what those gills are really helpful for. All right, and let's see, we've got one more thing I want to show you, I think. I want to talk a little bit about scales. So you really can't see the scales very well on the shark that I have just by me showing you, especially with the webcam, where the quality is just not really great. I first want to show you some scales from other fish, regular like bony fish, and then we'll look at the shark's scales under a microscope. So the first type of scale that I want to show you is from some kind of a bony fish, probably just maybe a red drum or a black drum. Whatever it was a fairly large fish because this is a fairly large scale. And these are the most common type of scales. These are probably what most of you guys are familiar with. They're found on most bony fish again. So even things like our goldfish, like our red drum, like our bass, these are probably the type of scales that you're used to seeing. They're really, really thin, and they're really flexible when the fish is alive. Then there's another type of fish called an alligator gar, which has a different type of scale. And these look very similar, well, kind of similar to some of the other fish scales, but they're much thicker, much tougher. They're almost like armor for this particular fish, which this was from an alligator gar. And it's a little bit tougher than your average scale. Now what I want to do is I want to show you how the shark scales are a little bit different. So again, I can't just really show you what it looks like just by holding him and picking him up. And I wanted to see what the shark scales would look like under our microscope that we have just right behind me here. So I took a picture. Let me fix this really quick. So I took a fin clip off of our shark here and I put it under our microscope. And this is what I saw. So again, it's a little bit better than if I were to just show you in front of the camera, right? But you still can't see those scales very clearly at all. But again, I still think it's kind of cool to see what it looks like. So what I'm going to do now is I'm going to flip to another picture. And this is from a microscope with a much higher magnification. So you can see very clearly what the scales look like. And these scales are called dermal denticles or placoid scales. And you can see that they're kind of microscopic. And what's cool is that you can see they're all pointing in one direction. And they're all pointing, all the little points are pointing towards the tail of the fish. So I'm going to stop sharing this so I can show you on our shark here. So all of those scales are pointing backwards towards the tail. So if I were to move my hand from like the shark's head down to his body, it's pretty smooth. Like I don't run into any resistance at all as I do that. However, if I want to try to move my hand from like the tail end towards his head, and of course you can't feel this because we're in a virtual webinar, but if you were, it would feel almost like sandpaper. So go ahead and raise your hand if you've ever touched sandpaper before. Yeah, so there's a lot of you that have done that. So that's pretty much exactly what shark skin has felt like. So if you felt sandpaper, you know exactly what a shark will feel like. And again, that's just because my fingers are getting stuck on all those, all those little hooks of the shark scales. And those, the fact that they point backwards toward the tail is really important too, because it keeps the shark really aerodynamic, and it allows the shark to move really quickly through the water. All right, so before we move on to like looking actually inside the shark, I want to ask you guys if you have noticed that I've been calling the shark a he. How many of you have noticed that I've been calling the shark a he? He or him? Some of you guys. So I do actually know for sure that this shark is a male. We actually, we have two sharks here that we're looking at today, and they're both male. So unfortunately, I can't show you how I know the difference between a male and a female, but if we flip our sharp-nosed shark over here, you can notice that there's two appendages on either side of his fins here. So these are called claspers, and they help with reproduction. So just by flipping the shark over, we can tell if it's a male or female. Males will have these claspers and females will not. So I wasn't just calling him a he because it was easier or whatever. It's because he truly is a male shark. All right, so we're going to kind of move into talking about some of the internal structures, but we're not cutting over to our dissected shark yet. I want to talk a little bit about the skeleton of the shark first, which I didn't cut that far into the shark to be able to show you the vertebrae and stuff on what we have here. First, I want to show you guys these vertebrae here. So these are from a bony fish. I don't know, again, what kind, but you can see they look pretty much like what you would expect a vertebrae to look like. This one has a spine attached to it as well. So this would be like the spine, one of the spines of the fish. And they're made out of calcium. So they're bony, they're like our bones that we have. Shark bones are a little bit different though. They're made out of cartilage, which is what we have in our nose and our ears. So I want you guys to take a second to feel your nose, feel your ears, and just feel how flexible they are compared to you wouldn't be able to bend your arm around, right? Hopefully you can't bend your arm around. But you can pretty much move your ears, move your nose. They're pretty flexible. So that helps to keep this shark able to move really quickly. And what's kind of cool is that I actually have part of a shark vertebrae here with me today. So someone was able to go in and remove a shark vertebrae and then preserve it for me. Again, I don't know what kind of shark this came from, but whatever it was probably a little bit larger than what we have here today. What's also kind of cool about the cartilage is that it's lighter than our calcium bone, so it helps to keep the sharks floating and buoyant in the water. Which is really important because they don't have a swim bladder. And I don't think you'll be able to tell, again, our webcam quality is not the best, but there's rings on these vertebrae. So scientists can actually count the rings on here to figure out how old a shark is. So kind of like if you were to go out and count tree rings to figure out how old a tree was, you can do the same thing with the shark. And one ring doesn't always equal 1 year of growth, but it's a close enough estimate sometimes. All right, so now we are going to move over to looking at our dissected shark. I'm going to shut the video off here and move over to a different camera. If you don't want to see this, either mute and come back in maybe a few minutes, or just leave the webinar now. So I will see you over at our dissected shark in just a second. All right. So you guys should be able to see our dissected shark here. This is another sharp-nosed shark, but it is not the same one that we were looking at earlier today. I'm going to try to get him a little bit closer. We're not going to spend a ton of time talking about some of these internal structures of the shark. I just want to point out a few very obvious ones that some of you guys might be interested in. So when we open him up, the first thing that you see is like this pale pink here. That's all the shark's liver. So sharks have really large livers. And that's really important. Again, I mentioned just a little bit ago that sharks don't have a swim bladder, and so they need to try to stay as light as they can or as buoyant as they can in the water. So one way they do that is through their skeleton, which is made out of cartilage that helps to keep them lighter. But also that liver is really oily, and all of that extra oil helps to keep the shark buoyant in the water too. And they have it's got 3 lobes to it. It's really big. So we can see the 2 really obvious lobes here and a much smaller one kind of in the middle. Let's see if I can angle that a little bit better. So the liver, it helps the shark with digestion, and it kind of acts as a filter for the shark as well. You may notice, I don't know how well the camera picks that up, but there's some green also. See if I can turn them around a little bit, but there's some green in the liver, and that is from the gallbladder. So that produces bile that helps with digestion as well. The only other 2 things that I really want to point out here, I'm going to move the liver aside for just a little bit, and you can see his stomach. Ooh, let me get this way. Where's the camera? There we go. So his stomach is going to be this organ here. I was hoping I'd be able to cut the stomach open and take a look at what the shark's eating. However, it doesn't look like there's anything in there, and it's still kind of frozen, so I don't really want to try poking around at it too much just because I don't want to slip and hurt something else. But that's where its stomach would be. And it's like a muscular stomach. It can expand and contract pretty well if the shark ends up with a large meal. So I'm going to put the liver back. And then the last thing that I wanted to point out inside of here is the shark's heart, which again, I'm hoping that we'll be able to get a good view of, but it's going to be that like brownish spot there, right up near his mouth. And again, that's helping to move all the oxygenated blood throughout the shark's body. And of course, there's other organs. We're kind of running out of time. So I just wanted to spend a little bit of time talking about those kind of really important structures. But I did want to leave time for questions. So I'm going to close again out of this screen. And I'm going to move back over here so you guys can see my face and we can ask or answer some questions. And it looks like we have a few here. So if you didn't type in any questions while I was talking, now's the time to do it. And maybe some of the questions that I'm answering will spark another one in your mind. So I'm going to pull up the questions now. Why doesn't the shark have that much blood? It does, but we dissected this shark last week and it was thawing, and most of the blood got stuck, like it already leaked out of the fish's body. So that's just why this one in particular doesn't have a ton of blood. The shark scales are called placoid scales or dermal denticles. Another question is, will this video be available to show students? Follow up with me after the presentation today. So you can email distance.learning@tpwd.texas.gov. And I can get you set up with a recording. I believe that we will also be posting, if not the entire recording, at least clips of it to our Facebook page later today. And that'll be true for all of our Shark Week webinars that are happening this week. As a reminder, we have noon webinars all week, plus an additional webinar with our game warden on Wednesday at 3 p.m. So please, if you're available, register for those as well. They're all free. We're going to be talking to some really knowledgeable shark scientists, shark researchers, and law enforcement about all things shark. What is the lifespan of this species of shark? So I wrote that down. Typically, they live to be about 18 years old. Females will mature at about 2 years old. So that's when they're able to start reproducing. And we know they're about 2 years old when they reach about 24 inches in length, so about 2 feet long. Males will mature at just over a year old, and they're about 25 inches long when they mature. Do sharks chew their food? Not really. They just kind of take big chunks out of it. How big does this species of shark get? Really only about 32 inches, so just about 2.5 feet long. So they're really small species of shark, right? And again, like I said earlier, when I think of sharks, I think, you know, the great whites that are 20 feet long, or you know, maybe even whale sharks, which are massive too. But that's not always the case. There are several, you know, smaller species of shark, like our Atlantic Sharpnose here. So what are specialized structures found only in some sharks for feeding? I don't know a ton about that. I wish I could answer that question for you, but I can't. What I can do though is I can look into that and talk to some of maybe our researchers here to see if they have any ideas, and then I can get back to you. So again, you can reach me at my email address, which is distance.learning@tpwd.texas.gov. And that's Texas spelled out. Does this shark lay eggs? Yes. So, and I believe that the females will only have maybe 1 pup a year. How long are they? So these particular sharks, The one that we had cut open that's dissected, that one was about 25 inches? 25 inches. And then our larger shark, the one that I was using for most of our presentation here today, this one, he was about 31, 32 inches long. So they're both mature adults, and this one is actually getting pretty close to like their maximum size too. How old are the sharks? So the smaller one, the one that's dissected, is probably a year and a half, maybe 2 years old. And again, I'm just guessing based on the length. The other one, I have no idea. I'd have to look at a graph to see their length and age comparison. And unfortunately, I just don't have that in front of me. All right. Any last minute questions for me before we log off here this afternoon? Well, I'm going to hold off for just a second, but I do want to say thank you so much for everyone for joining us here today. I know some of our stuff got out pretty last minute, so I'm glad that you all were able to make some time for us today. My email address, actually, let me type in that answer for you. And I think you all should be able to see it in the Q&A box, but it's distance. So it's distance.learning@tpwd.texas.gov. And you should also be able to find it on our TPW Discover website, which the easiest way to find that is just by Googling TPW Discover. Since it's 32 inches, are the bones weak? No, not at all. They're just about the same. Awesome. Thank you guys so much again for joining us. I'm not seeing anything new. Remember to register for the rest of our webinars. Check out our Facebook pages, both Sea Center Texas and our Coastal Fisheries Facebook pages. We'll be posting all the shark content all week. Lots of fun activities and crafts and story times and other things will be available. So please check us out there. And with that, I guess we will go ahead and sign off. Thank you guys for spending your lunch with us. I appreciate it a ton. Have a good week.